Number 9, we are given a number of different coordinates, a total of 6. A, B, and C are going to be the vertices of one triangle. I've marked it in purple. And then D, E, and F are the vertices of another triangle. I marked that in black. So the first thing that you would need to do is actually draw these out on a coordinate grid. I've done that over here, and although you're seeing it now, I would suggest that you actually practice doing that on your own. But you see the vertices, A is at -2, -2, B is at 4, -2, C is at 4, 6. That makes up the first triangle. The second triangle, D is at 5, 7, E is at 5, 1, and then F is at 13, 1. And the question that we're trying to determine is if those two triangles are indeed congruent. Well, in order to do that, we would use side, 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 or side, angle, side. We could even use something called hypotenuse leg. We do have right triangles here. We see that we've got a right angle in there at angle B and a right angle here at angle E. But really, I'd like to look at the side distances. This distance from A to B is a distance of 6 units, and from B to C is 8 units. Those are easy to calculate because they're horizontal and vertical. The same thing is happening over here. From D down to E is 6, and from E over to F is 8. And now we've got two sides, two pairs of corresponding sides that we know are the same. In order to really find the distance here, we'd have to either use the distance formula, or since it's a right triangle, we could use Pythagorean theorem. When we do that, we would get 10. And when we do that over here, we would get 10. Now, I wouldn't necessarily even have to do that because I know that I've got two sides that are the same coming off a right triangle. And so to find this, it would be 6 squared plus 8 squared equals c squared. And I would have the same thing over here, 6 squared plus 8 squared equals c squared. So you know they'd end up being the same. And so in this case, you've got three sides that are the same. We can say that by side, side, side congruence theorem, the triangle ABC is congruent to triangle DEF.